Hello everyone, this is Bruno again. I'm here to kind of wrap the day up. I've got about 30 minutes to go through some slides and some code hopefully and give you some interesting content here. So without further ado, I want to talk about programmatically creating content. Creating a web service. So that means no app config, no endpoints in a configuration file or anything else, just pure C# code consuming and exposing WCF services. Talk a little bit about security, and then one of my favorite topics, the Windows Azure Service Bus, part of the platform that is pretty useful for certain scenarios. So again, this is all about creating services and clients in code. I've talked to you a bit already about the flip case service in earlier modules. So let's take a look at how we might go about architecting something purely with code. So notice here on the left, we've got the client process. It's using the channel factory object to communicate over here to the service. And we have these channel factories and these channel listeners. Those are the mechanisms by which we can abstract away configuration and talk at a lower level. Finally, the underlying services over here, both in terms of the functionality of the code, and then of course the data here as well. So again, everything is possible programmatically. You're not forced to use configuration objects or configuration files. You can do it programmatically.
Yeah, and in fact, with the latest versions of WCF, I think one of the complaints of it all along has been all of the config. Everybody hates looking at the web config or the API, the app config. And they've really done a lot of work for what they call simplified configuration, where you can just write it and it'll go, okay, you need some endpoints. We'll imply the endpoints for you.
Right.
If you do configuration, you win. But if you don't, we'll build them for you.
And you can debate, which approach is more practical. Configuration, this notion of a declarative syntax is very popular in almost all programming paradigms. So, we're not here to tell you one way or the other. We just want to show you both ways. You choose the best option. So with that said, what I've done is to kind of expedite things along, I'm going to start Visual Studio over here. I think I have it up. I'm going to kind of close it down and start from scratch again. So I'm going to ignore this current project, close my project. So I think what you want to think about is just, there's going to be 4 projects here. One of the projects is going to be just for the interfaces and the data contracts. The second project is going to be the implementation of the service using the interface. The third project is going to be hosting the WCF service. And the fourth project is going to consume it. So I want to build these up one by one with you. Let's start with the actual interface itself. Much of this is done all with class libraries except for the hosting, which will be a WPF application. So what you're going to go do here is basically flip case service contracts. So this is just a project that will hold the interface as well as the data contract. But to make things a little more expeditious, I'm going to open it up, already kind of completed. Here you can see it. We've got the interface, which by now you've seen in previous posts, simply the interface, no implementation here. And we also have the data contracts. Now the reason you want these contracts in a separate project, why would we want to do that, Brett?
Well, if you look at it from a purely programmatic perspective, I don't want to have to rely on metadata. We bragged about how nice WCF is because it's discoverable, but maybe I don't want to discover. Maybe I don't want to share that metadata. Maybe I want to require my clients to know what I can do for them. And if they don't know, I ain't going to tell them. And so by putting those contracts off in another assembly, I can share that with them, and only those that have the magic assembly that describes my interfaces and my data contracts will actually be able to consume my services. Without that, they're out of luck.
Exactly. And not to mention, if I'm creating the WPF hosting service, it has access to the central location, as does the client, so I can kind of share it this way. So the next thing we want to add is the actual service itself. And again, we can do that just by adding a new project over here. And again, we're going to create a class library. This one's going to be called flip case service. And as you might imagine, it's going to leverage the contracts that we just created. So it looks something like this. It already exists here, so we're not going to add it. We're going to go to project number 2 here, which shows that guy in place. So if you notice over here, we have the contracts. By the way, the references are pretty straightforward here. If you look at the references for the contracts, of course it's got the service model and serialization, as we talked about. But if we go to the implementation itself, notice the interface file is not here. That's because it's setting a reference to contracts. And it has, of course, the service model and runtime serialization as well. So if you're talking WCF and communicating data across the wire, chances are you're going to have these two assemblies always there. So I had to add those manually by going here and adding a reference. And notice all I have here is the implementation. Get this data structure, loop through it, flipping the case, and then return back the result. Now, the third project that we're going to add is the hosting project. And that's going to be a WPF application. And you would just go over here and say Add, New Project, and you'd choose WPF. Now I've done that for us as well, so let's go ahead and just look at that project completed. Pretty straightforward here. Here it is. Here's that third project. And as you might imagine, that has a reference to the underlying contracts and the interface as well as the service, right? So it has references to both projects over here. So the WCF host talks to both of these ones over here. As makes sense, it's going to be communicating with that. In addition, it's going to have some very simple code here. Notice there's no real configuration information. If I open up app config, it's empty. Nothing to do with WCF declarative syntax. If I look at the visual interface, it's simply going to be a little host button over here. And if I look for the code at that button, if I double click, you'll see very simple code here. It's going to kind of use the using statement to create a service host. It's going to manually add a service. So here's the programmatic way to add the endpoint. Notice we're just going to do basic binding. This could be WS binding. It could be net TCP. You know, there's a whole variety of different objects or types that you can use here.
You know, and you were talking about the ABCs of endpoints and all that, and they're there, they're just backwards.
Right.
You got your address at the end, binding in the middle, contract at the front. Right?
It's all here still.
Yeah.
It's just programmatic in this case. So we could theoretically run and expose this service at this point. You could, you know, run this project. Let's go ahead and do that. And, you know, I'm going to click on the button over here, and it's ready. We just don't have a client right now. So it's going to be waiting here for a client. We just now need to add that fourth project to this. And the way you do that is you just go over here and add a client object, client program. So that's going to be a console app. So we'll probably call that console client, right? And which is the fourth one here. So let's go ahead and take a look at that one. So now we have all four. We have the console client, and again, no configuration information, blank. If we take a look at the code here on the client, notice that it's got some simple stuff. Remember early on we talked about the channel factory. So again, they have to agree, the server, the service, and the client have to agree on the ABCs. And you can see here, it's going to do basic binding as well. It already knows that's the endpoint exposed by the service. And then it's going to do the typical data we had before. We're going to, you know, pass in a case that we want flipped. We're going to call the method to do the flip, and then we're going to write the flipped case to the console. So that's it. We can actually run this service at this point and see it in action. Let's go ahead and say, run the service, host, get it to be hosted. It's live. Now we go back to the client, fire this one up, and run it. And sure enough, if all goes well, you can see indeed that it did flip the case for us. So it's that simple. No configuration, all programmatic access, and you be the judge what you prefer. It is kind of nice to copy around configuration files from project to project. Code's maybe a little more unwieldy.
Well, you know, even if you look at this, you say there is no configuration, but that doesn't mean there couldn't be, right? Because configuration is going to win over code, and code wins over convention, right? So you as a developer might decide, man, I understand this, I have control over this, it's more dynamic for me, I'm going to drive it this way. But if you deploy that service into an environment and the machine admin wants to change the bindings, he can do that through config, and config wins.
So what you're saying, Brett, is I can go over here to the WPF host and add additional endpoints here, and they would magically just be utilized by the system.
Yep.
Okay, fair enough. So that was an interesting example of WPF, the ability to kind of, number one, the lesson here was how do we create a central repository for the interface and the data contracts? How do we create a separate service that leverages those? How do we create a console client that leverages the contracts? And how do we create a host that leverages both the contracts and the service? So 4 pieces, pretty straightforward. Let's continue the talk. Okay, so now a little bit about security. We're not going to dive deep into this, but I will say that, think about a truck delivering money. The road that the truck travels on, that's think about that as transport security. And actually making the truck secure itself is more about message security, the payload in the truck. And so, the concepts over here basically say that you do it through a variety of mechanisms. We have a little chart here that kind of talks about this. If you go look on MSDN over here, all that is kind of described. Whoop, skipped ahead a little bit. Let me go to a browser and show you a little bit of those. I got those favorited in here. So let's go to favorites. Let's go to common security scenarios. And you can see here that there's quite a bit about various scenarios, much like you saw on this chart. What binding, what's the transport, what are your bindings? Again, it's back to the ABCs and how you configure those to implement the bindings.
Yeah, and the thing I liked about those scenarios that they had on that documentation page was they were telling you, here's the kind of authentication you're going to do, here's the kinds of clients you're going to support, here's the bindings that you have to have, here's the transports you can use. So they just kind of map it out, and then there's actually a sample code in there that you can use to walk through a scenario of how to actually set that up.
Awesome. So the next topic I wanted to get into is the Windows Azure Service Bus. Again, part of the overall platform, adds a lot of capabilities here. For example, you can see here, it lets you set up a pub sub. Let's say I have an app where I want to send information to a lot of people who want to subscribe to that information, supported. I want to do push notifications to a number of devices, that's supported. Let's say I want Brett and I to have our laptops communicate with each other, even though we're behind separate NAT layers and separate switches. You can use this relay in the sky as the clearinghouse to allow us to communicate, much like what Skype does. And in fact, it can actually allow you to do direct peer-to-peer connectivity should network conditions provision that.
Yeah, that's really cool. It can discover, I don't have to route all the way up there. You're on my same network. I'll just go direct.
Go to you. Yeah. And that's a lot of programming kung fu.
Yeah.
A lot of people describe that as Skype in a box. You can kind of just use it as is. A lot of this has kind of a main theme today. Can we discover what's exposed there on the service bus and kind of determine what's available? Can I iterate through collections of endpoints and discover things? And the answer is yes. Over here, kind of in an enterprise service bus scenario, can I take content, kind of repackage it, change it up, and then deliver it elsewhere in a new format, kind of acting as an intermediary, converting message formats? That's also supported. So in a sense, this service bus provides a lot of interesting capabilities. This is an upcoming article I have in MSDN Magazine with Ricardo. Essentially, many of you might not know what an Arduino is. It's a microcontroller that you can buy for like 40 bucks. And so a lot of innovation is happening here. You can prototype ideas. One of them is this open source project that lets you control your sprinkler system. Think about tomorrow's going to rain here in Seattle. Why should I turn the sprinkler system on? Wouldn't it be nice if my sprinkler system was able to talk to the web? That's one of the key attributes of it. Notice, by the way, I can have it talk to the service bus here as the intermediary. One of the approaches people are taking today is they're using virtual private networks and IPv6, but that has a litany of problems, particularly if your device is not under your physical protection. As soon as someone compromises that device, and that device is connected to the VPN, all devices connected to that VPN are therefore compromised. So the service bus provides a nice way for us to kind of protect our network and still communicate. We'll see another diagram that goes a little further than that in a moment. Also notice, if you think about a bigger, prettier diagram here, is we could have worker roles, Brett talked to you about that earlier, sending information to the service bus like commands maybe. Maybe the worker role is going to communicate here with the National Weather Service, get the weather, and then tell the Arduino, hey, tomorrow's going to rain, don't turn on. Meanwhile, you might have a Linux virtual machine running a Python script, and that Python script is going to, store and analyze data sitting out there in a NoSQL database or an Azure blob. Maybe you even have Azure websites where there's an administrator that's going to basically connect up to that web role and maybe, override the system, tell it water anyway, I don't think it is going to rain. You might even have Azure Mobile Services reporting back information back through push notifications back to the client. So there's a lot of interesting ways you can piece together the Azure platform to support devices, including the service bus. Let's take a closer look at what you could do with the service bus. Imagine that you have these devices in a building, building 1 and building 2. Further imagine that these devices are controlling temperature and shade control in these buildings, and essentially you want to be able to communicate with the service-side backend to know what to do next. Well, with the Azure Service Bus, you have this concept known as topics and subscription. So notice, for example, device 1 and 2 could write information over here to the temperature and shade response topic. It might report the temperature in the building or the amount of light, the ambient light. Well, you could have worker roles over here that subscribe to the temperature subscription, and this worker role would just get temperature information. It wouldn't get ambient light information. But this worker role here might be listening for shade information. It therefore has a subscription to the shade subscription. So this is a way for worker roles to get only certain types of messages that are put onto the service bus by a device. On the other hand, we might want to go the other direction. You might want to have this worker role over here send temperature information up to the device by publishing to this temperature and shade topic. And say device 1 over here wants to subscribe to commands about temperature control. So this notion of kind of topics and subscriptions is a way for the devices and back-end services to communicate very efficiently, to be able to segregate and partition the messages and communication patterns across the service bus. So this, again, you can find these diagrams in an upcoming article in MSDN Magazine. I thought I would share some of these diagrams we put together for the service bus. And I think I can demonstrate some of this. Brett, let's look at a little bit of that. I got a few minutes left, so I'm going to go here and program some of this for you folks. Let's go back to our friend Visual Studio, run this thing as administrator, and maybe show you at the portal what's going on over here. So let's go find our portal again. Here it is. And one of the things you'll notice over here is this piano-like thing is really a service bus. And what I could do is I could create this new endpoint in the sky. So for example, I could call this Bruno Service Bus sample, whatever I want to call it. And again, I can put it in one of the many data centers and say create. Now I've already done that. I've got one right here. Let's take a closer look at this. Let me dismiss all these running messages. I'm going to drill in a little deeper into this one here and look at connection information. This is kind of interesting. So that endpoint up in the Microsoft Data Center has this connection string. So if I want to send things into a queue up in a data center, this is kind of like similar to a SQL Server connection string. This is the way I talk to that relay up in the sky. So that's going to be a factor to consider in my application. Let's go back to Visual Studio and maybe create a sample of this and how you might use it. So I'm just going to go over here and create a console application and kind of blend all this together, writing to a queue. So let's just call this Service Bus Queues. I'm going to click OK. Make sure I've got the correct language. Here we go. So one of the first things I want to do is install some of the Service Bus SDK binaries, and I can go over here into Tools, library package manager console and issue those commands. So let's do that. Let's punch in the NuGet command here to install the service bus. Notice it's simply install package Windows Azure .service bus. Take just a few moments to kind of enable this project to communicate with the service bus. Those of you new to NuGet, it's very simple. It downloads and installs software and sets references, all in one simple command. You can see here, it added a number of different things here to my project. So at this point, we're going to go to my app config file and put in that connection string. So it kind of has one here right now. I'm going to put in my own connection string. So I'm going to get rid of this little template here and put in my own. And you've already seen this connection string. It's the same one at the portal. Endpoint, service bus, Bruno SB. So if we go back to the portal, it's this one. And it's really that quick and easy. Now I'm going to go back and write a little bit of code here to kind of show this in action. So let's go ahead and paste in some code here. Okay, excellent. So maybe set some references here. Add the service bus in here. Again, basically doing control period to let the system have the correct using statements. Actually, let me do this. So I think I want to replace this whole class here. Let's do it that way. Okay, so it has all the using statements here already. Now I'm going to kind of collapse this so we can kind of see the Reader's Digest version of this service. If you notice here, we've got our main, but very simple kind of syntax here. Create a queue. That's a queue that lives up in a data center that we're going to send messages. And I just basically send text strings up to the sky. And then later, I can receive these text messages. And this method here creates a simple message. And this little method over here handles the situation where I might lose connectivity and I need some retry logic. So let's just trace through this one line at a time, and you kind of get a sense for how it's going to work. You can kind of see that here. I'm basically going to create a queue. I'm going to send messages to that queue. I'm going to pause for a little while. Now, theoretically, you'd have some other device, some other system that's receiving these messages. I kind of rolled it all into one sample to make it easy, but this would probably be maybe a mobile device or another service out there that's got to read those messages. It might be something occasionally connected. So the messages that I send up to the cloud stay there until someone reads them. Now, of course, there's a timeout and so on, but generally speaking, they're persistent. So I'm going to hit the F10 key and start sending messages up there and kind of talk you through the syntax. So let's create the queue. I think you'll find that pretty straightforward. We'll work with the namespace manager, see if the queue, it does exist because I did run this before. Let's delete that queue and start a new one. So let's just create a queue. The queue name is right in here. It's just sample queue. You could call it whatever. You could have more than one queue, obviously. And that's it. Now we've actually have messages just sitting up there, up in the cloud, waiting for a client to connect to and consume them. So this might be, a device that has Wi-Fi that goes to sleep for a certain period of time to save energy, and then comes online every few minutes to see if there's any messages. So that's another challenge with these devices is, they might have limited kind of battery life. So you've got to use you can't be doing post get all the time with HTTP. You want to kind of use a queue. It's not just about security. So let's now go back to the code and send those messages in the queue. So we kind of are going to now, we got the queue created. We're going to now create a collection of messages. You can see just 1, 2, 3, 4. Now let's go and just loop through this message list here that you see. Here you can see the messages inside here. It's 3 of them. We just added them. let's now go and insert those. So we'll loop through, sending the message to the queue on this line you see here. Okay, we wrote one. Let's now go through the next message. There's only 3 to loop through. Send the second one. And let's now read or send the third one. Okay, so now, at this point in time, we have 3 messages waiting for us to be read. So theoretically, at this stage, now they're ready to be read by a client. So again, probably a separate application to do this. Just to make the demo easier, I put it all in one. And now let's go and read those messages with some simple while loop here. So I'm going to kind of make this full screen so we can see a little bit easier what's going on. So here we go. We're going to now receive a message. We just got it. There it is. You can kind of look inside of it. And you know, all that information is here. We're probably going to want to read the message body. If we go look to the right here, I can retrieve the message with this method here. So I'll do Shift F9. You can see first message here. Let me put in the zoom so you can see it. Hit the magnifying glass. So there, first message information. So it's there. It's also got a message ID. And let's print it to the screen. Read the second one, print it to the screen, and then when all is said and done, you will see that we've read all the messages here. So I think I paused too long and it timed out, so I'm just going to run it without debugging. So sending all the messages, there you go, all 3 sent. Now let's read them all. There you go, they're all read from the queue. So that's a nice little example that shows you how to put information up into a queue, up in a data center. It sits there and is ready to consume. Kind of a closing point I wanted to make over here is that we had talked to you about Windows Azure queues earlier on. I demonstrated that with that code example. And what I'm talking to you about is Azure Bus queues. And there's differences, and this particular article here describes those. Brad Calder and Haridas are the ones that kind of pioneered the Azure storage system, and so they kind of have a nice little description. Kind of the short version is that service bus queues go above and beyond. You can think of Windows Azure queues, those first ones, as computer science 101 queues.
Mm-hmm. Yeah, the way I think of it is, if you're looking for a queuing mechanism, the answer is Azure storage queues, until it's not. And then you move on to service bus.
And you know, if you want to implement pub sub models with topics and subscriptions, get a little more sophisticated, how you filter and broker these messages, maybe transform them, how you pull things off the queue, and more control, bigger size, more capabilities, the service bus.
Yeah, for me, actually, if I think of the Azure storage queues, I think they're among my favorite services. They're really easy to use. They give you an amazing, powerful way to create disconnected or loosely coupled applications. The demo I do a lot is I'll create the client app that submits the message into the queue, and the thing that reads the message doesn't even exist yet. How do you get more loosely coupled than that, right? But they're pretty basic. They're pretty simple. So as long as your needs are simple, Azure storage queues are awesome. If you need PubSub and you need those topics and all that kind of stuff, that's when you start moving into Azure Service Bus.
Exactly. Well said. Well, with all that, I'd like to thank everyone here today. Thank my brilliant colleague Brett here for doing a great job, and I had a good time. Brett and I are here if you guys want to reach out to us. We're easy to find. We enjoyed doing this. We hope to be back. Let us know what you want to hear about. We'll try to put together some content. Let us know areas that we should dive deeper in, what's popular. That's always good to know. Brett, do you want any?
Yeah, thank you very much. Had a great time.
Yeah, have a good week, everyone. Thank you.